Hi, this is Gunu Sairen, Assistant Professor for Mechanical Engineering at SNS Institution. Now we are seeing about case study on milling machine. Introduction is nothing but it is removing the material from rotating tool. It has a parameter cutting speed on the cutting blade, depth of cut. Okay, feed of blade and depth of cut. Okay, see introduction.
The milling machine starts as one of the most versatile and fundamental tools in the field of manufacturing engineering. It is an essential component in the machining operations where metal and non-metallic materials are precisely shaped into desired forms. A milling machine performs the functions of removing materials from a workpiece using a rotating cutter which has multiple cutting edges. Over time, milling technology has evolved from manually operated machines to sophisticated CNC and automated systems integrated with Industry 4.0 principles. This case study explores the evolution, construction and working principle types, modern developments, case application and challenges associated with milling machines in contemporary manufacturing environment.
Historical background. The development of milling machines dates back to the early 19th century. William Whitney, 1918, is often credited with inventing the first true milling machine to produce musket parts of US government. Later, Joseph R. Brown, 1961, introduced the universal milling machine capable for producing hexagon surface. The evolution of numerical control NC in 1940 and computer numerical control CNC in 1970s revolutionized milling by enhancing accuracy, repeatability, and speed. Today's machine incorporate mechatronics, automation, IoT sensors, and artificial intelligence, enabling real-time monitoring and predictive maintenance. The journey of milling machine mirrors the industrial revolution translation from manual labor to digital precision.
Working principle of a milling machine. Basic working principle of a milling is simple. Material is removed from a stationary workpiece by a rotating multi-tooth cutter. The relative motion between the cutter and the workpiece determines the shape of the final product. Basic operations. The rotating cutter has cutting edges that shear off material in the form of chips. The workable moves linearly in the X, Y and Z axis, allowing complex surface generation. The feed motion can be given either the workpiece of the cutter depending on the machine configuration. Cutting parameters. Cutting speed V. The speed of the cutter at the circumference meter by minutes. Feed rate F. Distance the tool advances per revolution. Depth of the cut. Thickness of the layer removed in one pass. The productivity and surface quality depend on the right selection of these parameters.
Main components. A typical milling machine consists of the following parts. Base supports the machine structure and absorbs vibrations. Column, vertically mounted structure that supports the spindle and overarm. Knee, adjustable component that supports the saddle and table. Table, provides snapping surface for the workpiece and moves in X and Y direction. Spindle, holds and rotates the cutter. Overarm and upboard support. In horizontal milling machines, these hold or upboard filling. Power feed mechanism drives the table movements. Control panel. In CNC milling, it houses input system for programming tool parts.
Types of milling machines. Milling machines are classified based on orientation, automation and functionality. Based on spindle orientation. Horizontal milling machine. The spindle is horizontal, ideal for heavy-duty operations like slotting and gear cutting. Vertical milling machine. The spindle is vertical, used for precision surface milling and drilling operations. Universal milling machine combines both horizontal and vertical features. Based on control system, conventional milling machine, operator controls movements. NC milling machine uses punch, tape or basic programming. CNC milling machine, fully computerized, capable of complex 3D operations. CNC machine centers, multi-axis automation, tool changers and high-speed spindles. Axis milling machine enables machining of intricate aerospace and automotive components. Special types. Turret milling machine has a stationary spindle with a movable table. Bed-type milling machine. The tables move longitudinally and the spindle moves vertically. Planet-type milling machine designed for large workpieces. CNC gantry milling machine used in aerospace and mold making for large parts.
Tooling and work holding devices. Milling operations rely on precision, tooling and secure work holding. Cutting tools are end mills, face mills, slab mills, fly cutters, gear cutters, ball nose cutters. These tools are made of HSS carbide, cement or PCD materials for enhanced wear resistance. Work holding devices are machine vise, dividing head, rotatory table, fixtures and jigs, magnetic chunks. Proper clamping ensures accuracy, safety and surface quality.
Milling operations. Plane milling, surface parallel to the cutter axis. Face milling, surface perpendicular to the cutter axis. Angular milling, cutter set at an angle to work surface. From milling, produces irregular counters. Slotting and key cutting, produces slot for mechanical joints. Gear cutting involves indexing with dividing heads. Hexagonal milling, for producing